It's all, if you haven't guessed, I mean, it's quite a tenuous link. It's all around cloud native data formats. Don't worry if you don't know what they are. We will go into details, and all about a certain database called DuckDB. So it's a tenuous link, but not a bad effort there, Dave. Well done. So we are all familiar with the fantastic CSV and the Shapefile. I guess we decided to be polite and call them the old guard. Yeah. Or just, yeah, there's other terminology for them, but that's the polite one. And we now have some new, relatively new formats on the block. And I don't think, I kind of feel quite strongly about this, that no event that we run should go without talking about formats till, and be passionate about new formats. And I'm actually quite passionate about a couple of these things. So cloud native formats, there's a few kind of formats on the block here. There's Parquet. So this is, I guess, trying to be the replacer or the new incumbent compared to CSV. It enables you to store tabular content, but also vector content as well. FlatGeoBuf, which we're not going to cover too much, is another kind of Parquet equivalent, but more tailored to handling vector geospatial data. And then there was one called GeoParquet. However, spoiler alert, GeoParquet and Parquet are now one of the same thing, and I'll explain a little bit more later. To use these formats, you can use FME. That goes without saying. We actually announced it in, as I was mentioning, like 18 months ago in the 23.1 release of support. But if you really want to start using it for analysis rather than reading and writing, then there's a new bit of tooling that comes into play, which is DuckDB.
Yeah, so we're all familiar with CSV files, and I wanted to find a very large amount of data that we could potentially go and download and do some analysis of. So, sorry, it's England and Wales. You have got your own equivalent, but it's only about 800 meg in terms of a download, whereas this one is a very large file. It tells us it's 5.4 gigabytes as a zip file, okay? And that's 64 million EPC certificates, historical as well, across England and Wales. And when you extract that, that's 40 gigabytes of data, not to be sniffed at, okay? And when we look at the structure, it's folder upon folder of local authority with 2 files in. Certificates, which is the ones that we're interested in, which is always the larger file, and then some recommendations for essentially making your property more efficient. So we focus very much on the certificate side. So if we would say 50-50 split, maybe, I mean, certificates tend to be a bit more larger in size, then we're still talking about 20 gig of data, okay? But before we sort of move on to how we might treat that a little bit differently in FME and some alternative formats, we should probably explain a little bit about Parquet as a format. So CSV, as we know, is readable in Notepad, so we can open it up and look at all the comma separated values or tab separated values, and it's human readable, it's fine, but it's not very efficient to read, because we have to read the whole file before we can do anything with it. Now Parquet is slightly different, and it's all about efficiency, okay? So it's not a file that you can open up in a Notepad. It's binary, it's built for speed and for querying, and it basically consists of what we call row groups and chunks of columns, and more importantly a lot of metadata about that file, and we can query the metadata to basically allow us to navigate to the bits of the data that we want to get. So we don't have to load all the data. If I don't want, you know, a number of columns, you know, the EPC certificates, I think there's 93 or 98 columns in there, probably only interested in about half a dozen, okay? Parquet actually, just as an aside, it's used quite a lot in data science, and what they will do is basically just have a massive file with hundreds of columns with all their data in, and then different scientists will look at different columns of the same data, so we don't have to keep sort of replicating the data in different formats and different configurations, so we can just have it in one massive file. So it is built for speed. And the other thing is that it is, I hate this word because I can never say it properly, columnar. So it's column-based storage as opposed to row-based storage like a traditional CSV. So I've coloured each line there in different colour, which probably messes with your eyes because he's colourblind. But we have to read the whole file, okay? So if I want to know what the highest age of, you know, hockey player is, ice hockey by the way, sorry, reference, you know, I would have to read the whole data and then do a query on it to work out who the oldest player is. So, you know, between Brad Marchand and Sidney Crosby, both great players, just play for the wrong teams. And, that is, it's consuming of resources. If you were to load in all the NHL players and historical players and stuff, that's quite a lot of data. So it would be much easier if we have column-based storage. Sorry, colours are the same, but now used in columns. So if I'm not interested in their position or their nationality, I just don't have to read it in at all. Okay, and that makes things a lot easier, and that is basically almost the key to that. So the columnar storage is efficient, and when you combine that with the metadata and the groups of records, we can quickly discount data with a query. So if it's not in a range that group of records has, just doesn't read it. It just moves on and keeps going until it finds the data that is relevant. So what we can do with DuckDB is start issuing SQL queries at a file, and that's what we're going to be looking at next.
Excellent. And just to say, Parquet is an open format. It's an Apache standard, right?
Yep.
So this is an open data format we're talking about. There's nothing proprietary about it. Same as DuckDB, completely open source database, came out of the Netherlands, which was, really, really nice. And it's kind of grown and established itself over the last couple of years at most, really. Yeah, it's kind of crazy. So it's not like a contender to SQLite or Spatialite or Postgres or PostGIS. It's a database designed for data analysis and reporting. You are not going to be putting in records into this in like individuals or doing updates. It's really specifically designed for data analysis. And what's really neat about it is that you can have a database with no tables in it, because in the from requests, you can literally go from Parquet file. Yeah. And to me, that's just wicked, because you can write SQL against files, which if you're familiar enough with SQL, then you're gonna find this quite interesting. Yep. The other thing that's also really nice about it is you can run it entirely in memory, and we will demonstrate that very soon, I suspect.
Like right now?
Right now. Off it over to you.
Okay. So we're going to look at that EPC certificate data that I showed you. Incidentally, I took that 40 gigabytes of data. No, maybe I'm going to spoil that. No, I'll talk about that in a bit. I think that's a spoiler. Might have spoiled it. Anyway, the EPC certificate data is going to be read in, and I'm going to join it to the OS Open UPRN. So the EPC certificate data has got UPRNs against it, so naturally it's not spatial, but I can join it to the OS Open UPRN data, which is spatial, and do a join using a SQL query. So I'm going to show you a couple of things that we can do here. So I'm just going to kick this off and run. But I've got a number of SQL executors here, and the first one is literally just doing a count. So if we've ever done select all count from a data set, you'll see instead of a table name, as Oliver alluded to, I've got read Parquet, and I'm pointing at a file in the same directory as my workspace is located. So that's the FME MF directory. It's a special user parameter that you can reference. So I'm not pointing it at a SQL Server database and looking at a table. I'm literally just pointing it to a file that is locally stored on my machine. So that's the first one. We're going to do a count of all the records that are in there. And if I look at that result here, we can see that there are 26. I think I over-egged it a bit, didn't I?
Yeah.
Yeah, 26 million. Yes, 26,565,933. So there's quite a lot of data sat in that. So that's just doing a very quick count. And then there's a neat function where I can summarize the data. And there's a special command in here called summarize select all from that Parquet file. And what that does is it gives you information about all of the columns in there. So it gives the highest and lowest values for a particular column, gives you standard deviation values against it if it is a numerical column, and it gives you a percentage of nulls, so that's quite useful from a data quality perspective.
I was just going to say as well, the other thing is that a Parquet file format, it contains the schema of the data that it holds, which is something that a CSV doesn't do. Yeah. So you can see that column type right there.
Yeah. So we've got all the column names, the column types, the count of the records, which is nice and consistent across there. And then we've got minimum, maximum values, and then we've got like 25th percentile and 50th and 75th and the standard deviation values for anything that's numeric, and then any null values in there as well. So, that can be run across quite a large file and generated reasonably quickly. And then this last one is me doing a SQL join onto files that are stored, again, in this case, locally on my machine. So, nothing too crazy, just joining on a common value, but again, just reading from 2 Parquet files, okay? And I've said that I want to have a join on the UPRN, and I'm only interested in energy ratings A and B, and I've got to make sure that the local authority label is not null, okay? And that performs that join pretty quickly and brings back 2.9 million records out of the total set of data. And to run all 3 of those processes, if we just check here, just took 42 seconds to do that, okay? So it's quite efficient with the way that it works. Okay, I think I'm handing back to you, Oliver.
Quick question.
Oh, sorry.
You
Yeah.
could interrupt, that's okay.
Yeah.
AI assist. How do you find it? Does it work writing those SQL queries?
Yeah, it's a good question. So yes, but you will need to make sure that you change. So it's not tailored to DuckDB just yet. I don't think that might come. But
So it's if you use SQLite, Spatialite, Postgres, SQL Server, Oracle, it's excellent.
Yeah.
DuckDB, no,
Not quite
yet.
there.
But maybe in the next release.
But the documentation around DuckDB is actually really good. So, there's, if you go to duckdb.org, I think there is a whole plethora of information around that, because there's, it's actually bigger as a sort of platform than we're talking about. There's whole loads of different extensions and modules that you can import in and use inside of FME as well. So if you want to work with SQLite, you can use the SQLite module and import and then query SQLite through DuckDB in memory. So it's super cool. This was the spoiler. So could we use GeoParquet as a format for future delivery? Okay, so if you've got data that maybe doesn't change that often, but it's a huge volume of data, how about we deliver it in Parquet format? Okay, so that 40 gig of data is now 2.5 gig. Okay, and that's exactly the same data. And if we store it in an S3 bucket, as we'll see, we don't even have to download it.
Oh, and also to say, well, Simon gets, that is a compressed Parquet file.
Yeah.
So basically, it hinders it's detrimental to performance, but you'll still find that it's very, very good. Whereas obviously, if you zipped up some CSV files, there's no chance you're going to be able to read them until you've unzipped them, right?
Yeah.
So there's some extra value to this format, and the fact that you can read it even in its compressed state.
Yeah, and what we've got here are 2 SQL executors. The top one is querying the data locally, and then the second one is querying it from an S3 bucket in the cloud, okay? So that has done both of those reasonably quickly. What's that? 37 seconds, okay, to do a SQL select. So it's the same query as before. So this is the local one, and we're doing that energy rating of A or B with null local authority and UPRN. And then the second one is doing exactly the same query, but the magic bit is this here, okay? It's now in an S3 bucket, okay? This just happens to be a public S3 bucket. All right, you can put in connection details to Amazon S3 buckets and to Azure blob storage through secret keys and things like that. So you can do that in the SQL statement itself. But for ease and for sort of decomplexify it, that's public data. So if you wanted to hit that URL with your own SQL executor, it's there to query. And the key thing about that is it didn't have to go and download that 2.5 gig of data, just went there and used a special thing called range requests to basically selectively draw the data that it wanted back, okay? So now we've got a scenario where I don't have to go to an open data portal, download 40 gigabytes of CSV, they can just be in situ and I can get to it without having to, worry about, when did I last download it? The ones that I've got here in file, is that the latest version? And stuff like that. And it just opens up a whole new opportunity for accessing data. And actually, just to finish, so what if it takes a bit longer? It doesn't really matter, because if I had to download that 2.5 gig file first, that's time out of my day to hit the download button and get it, put it somewhere, create the workspace around it. So if it took 30 seconds to query, I don't think it really matters too much at all.
Yeah. I think given time, we might just finish on the different data sources.
Yeah, okay.
I think,
Yeah.
we're a bit squeezed.
Okay, fine.
So there's a couple of, well, turns out some charities and some organizations have come together and already are starting to use these data formats to deliver out data. So one of them is Overture Maps. They expose, as it says, over 2.5 billion building footprints in this way. You don't need to download all of that volume. You can just do your bounding box and pull that down. Yeah, quite a lot of addresses. The points of interest ones are really quite fun and worth having a look at. So really amazingly huge open data sets out there in really usable formats for, I think, the first time kind of ever, which is really quite exciting. Once you go to the site, you'll see that you can go and explore the data. So this is a little bit of a site as to where we're based. And there's also another not-for-profit called SourceCoop. There you can become a publisher of data sets. So for example, if you don't have funding to set up your own API and provide a whole environment or ecosystem for delivery, you can basically register with this organization and deliver out massive volumes of data just in these native formats. I think, very quickly, just to mention, Parquet now, the latest release, supports geometry and geography. I hope that it will be that version with 2025.1 release.
Yeah.
I would be surprised if it wasn't.
So, we're not saying that this is a replacement for shapefiles, because there's always, a piece of my heart, very small, that is still, there for shapefiles, and it's not going to replace CSV files. And if I've got a legacy system, I'm going to export a load of data and then maybe use a CSV file to then import that into a new system. I'm not going to be using anything like Parquet for that. But if we've got a format that allows us to access data without any infrastructure on the basic building blocks of cloud, then let's use that. Let's make it the single source of truth. Let's cut down on the infrastructure and the maintenance of the overhead of, web servers to serve that data up when we can just serve it in situ. So, it is kind of about understanding the problem and whether this format will solve it. It's not going to solve everything, but it's definitely something to be considered in the sort of the data toolkit, if you like. And that's kind of it. But I guess the most important thing is that FME will support it, both old guard and vanguard, really. So if there's anything else you want to add, then I'm done.
Yeah, thank you very much.
Superb. Lovely, thank you.